Hi everybody! Welcome to the Joy of Coding at Portland State University. Two of the most fundamental and practical data types in computing are text and dates. Textual data can easily be consumed by the people who work with software, certainly more easily than binary data. Dates and times represent the temporal aspects of events that happened in the past or are expected to happen in the future. The Java programming platform contains rich APIs to represent and manipulate date and time data, as well as APIs for working with textual data. Leveraging these facilities are key to building software that is accessible to people from around the world. Let's take a look. So in this set of slides, we'll learn about how Java works with dates, times, and texts. And this is taking any type of data that you have in your program and making it more readable by a human. By taking a number that's represented as binary and putting it out as digits. Taking a date that is represented somehow internally and making it visible to the user in a way that makes sense to them no matter where they are in the world. Now, when you're working with dates and times, there are many aspects to take into account. Different people in different parts of the world have different calendaring systems. Just like with any piece of data, when you represent dates and times to a user, you want it to be in a format that is familiar to them. So this means you need to take into account things like time zones and daylight savings time. Java has a suite of APIs that have evolved over the years to make sure that we have facilities for working with dates and times that behave as expected for anyone in any part of the world. The java.util.Date class has been around for a long time, and it basically represents a point in time. It's the number of milliseconds since the epoch, which is midnight on January 1st, 1970. And this is represented as a number. A positive number is a date, a point in time, that is after January 1st, 1970, and a negative number is a date before January 1st, 1970. The date object has some very helpful methods. It has a method called after, which determines whether or not one date occurs after another, and similarly, there's a before method. You can also get the number of milliseconds since January 1st, 1970 by invoking the getTime method, which returns a long. If you create a new date object using the zero-argument constructor, it represents the current date time. Like I said, the date class has been around since the first release of Java, and if you look at the API now, you'll see that it's a little dated. There have been a number of methods that have been deprecated, meaning you shouldn't use them anymore, and for good reason. In hindsight, the date class contained too much functionality. It did not observe the single responsibility principle. Instead, the API authors decided to place that functionality in other classes, like java.util.Calendar and java text date format. This provides support for internationalization as well as multiple daytime formats. It provides a little bit of complexity, but through that complexity provides a lot of power. If you want to see an example of this, I recommend that you check out the Around the World program. So while a java.util.Date represents that point in time, a java.util.Calendar provides information about that date. So things like the day of the week or what year it is. The calendar class has a number of static fields that are ints that represent various attributes of a calendar, such as the day of the month, the year, and then the hour, minute, and second of the time. Now, admittedly, this API is a little bit old. If we were doing this now, we would use enumerated types to represent these things instead of ints. But if you are going to use the calendar class, here's how you do so. After you get a calendar instance, you can invoke methods on it like setTime to associate what date the calendar is operating on. And then you can manipulate that date using methods like add, which will increment or decrement, if the number provided to it is negative, one of the fields within the date. So for instance, you provide the month constant and a number of months that you want to increment it by, and the calendar object has the logic for updating the underlying date appropriately. You can also use the get method to return the particular value of a date's field, like the day of the month. Now, if you look at the API, you'll notice that all of the constructors of the calendar class are protected, which means because your code is outside of the java.util package, and if you're not going to subclass a calendar, you can't directly instantiate a calendar instance. So how do we work with it? Well, there is a static method on calendar called getInstance, which will create a calendar instance that is appropriately configured for the system that it's running on. By hiding the exact details of how a calendar is created and the specific type of calendar that is created, it frees up your program to be more general in what it does. and delegates the responsibility for understanding which locale it's running in, which calendaring system is used for that particular runtime environment, to program execution time. Now let's take a look at code that leverages the date and calendar classes to print out some information about the current day. Because date and calendar are in the java.util package, we need to import those classes. And here in our main method, we do the following. We first create a new date instance, which represents the current date and time. And then we get a calendar instance by invoking that getInstance method, and we associate the current date and time with that calendar. Now we can use that calendar object to get information about that date. So we can call the get method on the calendar with the constant day of the week. That'll return, well, the day of the week, similarly for the month of the year and the week of the month. Now we can create a string with a bunch of information about the date, which is ultimately printed to system.out. So we append the date object itself to the string builder. That will automatically invoke the toString method of the date object. Then we'll call the getTime method on today to learn how many milliseconds since 1970 it's been. And then we can print out the day of the week, the day of the year, and then the week of the month. When we run this program, we see the following output. Recall that we printed out today is, and then the toString value of the date. And on the machine that I ran this on, the date's toString method formats the date as the following. It provides Sunday, an abbreviated month, the date of the month, the time in 24-hour time, the time zone, and then the year. The second line of output contains the number of milliseconds since 1970. Because it was a Sunday, it was the first day of the week, and November 12th was the 316th day of the year in 2023. And we're in the third week of the month. Beyond providing you the ability to get information about a date, there's an important pattern in object-oriented programming which is on display here. So we have separated out the representation of a date, as that date object, from how it is accessed. And this makes the time facility more modular and gives you a lot more options for customizing how you work with dates based on the preferences of your user. Because of this flexible facility, Java easily supports multiple calendaring systems. So if you go and look at the API, there are some subclasses of calendar that represent things like the Gregorian calendar, which most people in the West are on, the Hebrew calendar, the Chinese calendar, really any kind of calendar that you want. And they add more over time as there's more demand for localization. Just like the calendar class abstracted out how dates are accessed, the date format class is responsible for converting a date to a string and a string to a date. It does this via its format and parse methods, respectively. Date format also has some constants associated with it, which represent date format instances that format dates and times of various length. You can have short, medium, long, and full. As you can see from these examples, they have increasingly more information about that date. Date format is another one of those classes that you don't instantiate directly. Instead, you can acquire well-known instances of date format using methods like getTimeInstance. For getTimeInstance, you pass in one of those constants mentioned above, like dateFormat.medium, and that will return a date format object that formats and parses a time in that format. Similarly, for dateInstance, you can get a date format that just formats and parses a date. If you want both a date and a time instance, you call getDateTimeInstance. If you want to format or parse both a date and a time in one string, you would use the getDateTimeInstance method and pass in two of the constants, saying the size that you want for the date and then the size that you want for the time. Now, when it comes to parsing a date, you can control how strict the parsing should be. Should it tolerate things like a 2-digit date when your format wants 4? And you determine how strict parsing should be by invoking the setLenient method on the date format instance. Here's an example of using the date format API that concatenates the arguments on the command line into a single string, which is then parsed and formatted using date format. Note that we need to import classes from both the java.util package and the java.text package. The first thing that we do in our main method is take all of the command line arguments and join them together in one string separated by spaces. We want to take that big string that we just created and convert it into a date object so that it can be formatted. So ultimately, we're looking to get a date object. And the format of the text information passed on the command line will be in date format.medium, which is, again, sort of a medium length format for date and or time information. We want to parse that string using a date format object. And because it contains both a date and a time in that medium format, we invoke getDateTime instance on date format, again a static method, passing in for the format date format.medium. Once we have our date format instance, we invoke the parse method on it and provide it with that string. This will return a date object that represents the string that was passed in, or if there's a problem parsing the string that was passed in, a parse exception will be thrown. In the second half of the main method, we format the date that we parsed in different formats. We'll do it for short, for medium, for long, and for full. And we format a date by invoking the format method on the date format and providing it with the date object that we want to format. So when we run this program and provide it with the arguments JUN, abbreviated June 17th, 1994, 9:37:45 p.m., this program concatenates those strings, parses a date object from that string, and then formats that date object in several formats. There we see the short representation, medium, long, and full. The APIs we just saw, java.util.Date, Java text date format, calendar, etc., were really great. They get the job done pretty well. However, over time, there were some deficiencies discovered in what these APIs do and what they can't do. The Java API authors introduced a new package called java.time that addresses many of these deficiencies. First off, the java.time APIs are based on what we can think of as first principles when it comes to working with dates and times. So they have objects that represent an instant in time. They have good support for durations, for time zones, the things that are very practical in real world when it comes to working with dates and times. It's based upon the standard ISO calendaring system, so it's not unique to Java in any way. The vast majority of objects in the java.time API are immutable, which means they don't change. And as a result, they are thread safe. You don't need to worry about race conditions because the data never changes. The java.time APIs are designed so that they're compatible with older date APIs, so you can go back and forth pretty easily. They have good support for leap years and leap seconds, which is just a reality of working with dates and times. And also, they have built-in support for nanosecond granularity, which is an option that's available on modern hardware systems. So within the java.time APIs, there are a handful of packages. There's java.time, which has the fundamental classes that represent dates, times, and time zones, things like that. Time zones are always tricky, and actually they change kind of often. So there is a separate package which just contains a bunch of rules for figuring out how the time zone impacts the time. There's the java.time.temporal package, which provides APIs that allow you to modify dates and times, some nice object-oriented abstraction here. Similarly, the code for formatting dates and times will be found in the java.time.format package. And then there's a java.time.chrono package, which supports non-default calendaring systems. Again, very flexible, very powerful, some amount of complexity, and so then a lot of packages are required. But all this enables Java programs to support many different date and time capabilities with the intent of having an API that will be flexible and extensible enough to handle changing needs into the future. Now let's take a look at some of the fundamental date-time classes in the java.time package. The instant class represents a point in time. Much like a java.util.Date, it represents a number of milliseconds since the epoch. There are a couple of classes that begin with the word local, like local date, local time, and local date time, that represent a date and or time without a time zone, so 2:37 p.m. Offset time and offset date time represent a date time with a time zone offset. So not a time zone with a given name, just one offset, like -7 hours GMT. A zoned date time represents a date time with a specific time zone, like Pacific Daylight Time, and all of the rules associated with that. Also in java.time is the zone ID class, which represents the time zone. There's a subclass of zone ID called zone offset that is relative to Greenwich Mean Time UTC. There are also classes that represent portions of a date, like its year, month, month day, things like that. Java.time also has classes that represent a duration, right? The difference between two particular points in time. You can measure the difference between two parts of a date, like a year, number of months, number of days, using the period class. Now, as I said, the datetime objects in java.time are immutable, which means that once they're created, they can't change. And this is actually really great for a number of reasons. It helps programs be more efficient and removes the possibility of race conditions between two threads that are working on the same object. But it does have some impacts on the API. In the java.time APIs, you find yourselves working with static methods a lot more than you do invoking constructors. So for instance, if you want to get a local date time that represents the current time, you invoke the now method, which is a static method of local date time. Similarly, there is an of method that will return a new local date time instance associated with the year, month, day, hour, etc. that you provide to the of method. And if you want to convert an instant object to a local date time, you can do so using the static of instance method of local date time, providing it that instant object, and then also a zone ID object. So immutability impacts how you create or get access to instances of these datetime objects. It also impacts how you modify the objects. So if you have a particular instance of local date time and you want to change something about it, like incrementing the hour, you use methods like withHour to set attributes, and then to make other changes to it, you can also use methods like -days and +years. Now the benefit of this is that immutable objects are inherently thread safe. If all threads can do is read the value of an object and that value never changes, you don't need to worry about race conditions. Doesn't matter who got there first, they're always going to get the same value. It might take some getting used to, but you'll see this pattern has some benefits, and you'll have an opportunity to use it across many classes in the java.time API, like instant and zone datetime. On the previous slide, we saw how we can modify a date or time object. If you want to get information about a date or time, if you want to interrogate the object, there's an interface called temporal field that aids this. Objects like local date time have a method called get that takes a temporal field instance that specifies which attribute of that local date time you want to access. You specify which temporal field you want to use by leveraging an enum called chrono field, which has constants for the hour of AM or PM, the epoch day, how many days since 1970, the day of the week, etc. Here's an example of using the java.time APIs for getting information about the current date and time. We import the classes that we're going to use, so in this case, local date time and chrono field. And in the main method, we get the local date time object that represents the current date and time. We'll print out its toString just to see what it looks like. And then we'll work with that object. The first thing that we're going to do is get the day of the year by invoking the get method on that local date time object and provide the day of the year from the chrono field enum. Then we'll invoke the -days with a value of 1 to get a local date time that represents yesterday, or the current time 1 day ago. We can create a new local date time for a specific date by using the of static method of local date. This will create a local date time that represents January 1st, 2024. And when we run this program, we see the following output. We see the toString value of the local date time for the current time, and look at that format. It has the year, dash the month, dash the date, and then it has the letter T to specify that you have a time now, And so the time is, well, 1400 hours. So 2 p.m., 9 minutes past the hour, 42.792780 milliseconds past the second. It's the 316th day of the year. As you can see, yesterday was November 11th, at exactly the same time. And note for New Year's, it has the year, the month, and the day, but the time is merely 0 hours. Because there were no milliseconds specified when the local date time was created, it's not output in the toString. In the java.time API, each of the date time types has methods for formatting itself to a string and a parse method, which will take a string and return an instance of the appropriate date time object. The format that's used to parse or format the string is specified by an instance of datetime formatter. So once again, all of the logic and configuration for formatting a date or time is kept separate from the object that represents the date and time itself. Datetime formatter has static fields which refer to pre-built instances that represent things like the local date time in ISO format, the standard ISO format for the week and the date, etc. Datetime formatter also has an ofLocalizeDate method that will return a datetime format that specifies the overall length of the format, ranging from short to full. Datetime formatter also has an ofPattern method, which allows you to provide a string which specifies the format that ultimately will be used to parse or format a string. And within this format string, specific characters or symbols have a particular meaning. For instance, lowercase y represents the year, capital M represents the month, and little d the day. Hours, minutes, seconds, and milliseconds are also available in the patterns format. You can also have text within your format, but it must be escaped with the single quote. Let's take a look at the datetime formatter API in action. This is a simple program that formats the current date time using a format pattern that is provided on the command line in the first command line argument. The main method invokes the ofPattern method on datetime formatter and provides it that first command line argument. Then we invoke the now method of zoned datetime to get the zoned datetime instance that represents the current time. So this is the date, the time, and the time zone of where the program is being run. Then we invoke the format method on that and provide it the datetime formatter object that we created in the line above. And that will return a string that contains the formatted zone datetime. And then we simply print it out. And when we run this program with a single command line argument that leverages those formatting symbols from the previous page, like capital E, big M, D, all that kind of stuff, we see the following. So I ran this on Sunday, November 12th, 2023, in the AD era. I say at 4:04 p.m. PST. Notice here that the word at had to be escaped in single quotes in my datetime format. Now note, with these formats, the more times a symbol occurs, the more verbose the format is. So if I run the program again and provide it with a format string with a little bit more information, you'll see that instead of abbreviating the day of the week as sun, it becomes Sunday when you add 4 E's instead of 1. Similarly, for the month, instead of the numeric value of the month, 11, you have an abbreviation of the name of the month, which is November. So once again, with the java.time APIs, we've seen how the presentation of a date, which you obtain via a datetime formatter, is separated from the date itself, representing it as like a local date time, or as we saw in the previous example, a zoned date time. By providing different objects to handle these different responsibilities, it allows us to display and parse dates in a variety of different ways. Another key component of datetime formatting is something called the locale. And there's a class that represents locales, java.util.Locale, which is just a particular language-country combination, like the language being English language and the country being the US. The implementation of these Java APIs support a continuously growing number of locales that enable Java programs to be run any place in the world. And these locales are consulted when performing operations like formatting a date and time. So for instance, if you're running in the France locale, a date will be formatted using the French language words for the day of the week and the month of the year, and also in a format and an ordering that is familiar to people who live in France. And I think that's a good place to stop this screencast. As we saw, Java has some very rich APIs for representing and working with date and time data. We saw the original java.util.Date APIs that you're likely to encounter in older Java codebases, as well as the newer APIs in the java.time package that provide flexible support for representing and formatting dates and times. But we're not done yet. In the second part of this slide deck, we'll look at Java's facilities for formatting arbitrary text to create output that is readable by the people who use the software that you develop. So, I encourage you to check out the next screencast for The Joy of Coding here at Portland State University.